Okay, we're going to talk about angle pairs. Angle pairs, there's two of them, just like your pair of shoes. And there's different types that have two angles that have a name. So here we go. The first set are called complementary angles, and they are basically two angles that add up to 90 degrees. Not one angle, not three angles, but two. Okay? A 60 and a 30 adds up to 90. They're complementary angles. Okay? They can be connected. You don't even know what size these two angles are, but we know they're 90. They add up to 90 because of the box, right? So these two angles would be complementary angles, even though we don't know what size they are. We just know they add up to 90. Okay, if this one was 25, then how would you find this? Well, 90 minus 25 is 65, right? There it is. Next, uh, if you have complementary angles, they add up to 90, right? And they're complements of each other. And they're not sitting around complimenting each other, saying, "Oh, you look so nice, 60, and 30, you look so nice." Compliments are kind of like synergy, where things work together. They work together to help each other out. Like a police station and a donut shop. Oh, no, no, that's probably pretty bad. I probably shouldn't even say anything about stuff like that right now. Uh, anyway, how about a high school and a McDonald's, or a high school and like Poteet has a high school and a Little Caesars next to it, or a Whataburger across the street. We're about to have a Cane's Chicken, right? That's they're complementary pieces. They help each other out. Anyway, so complementary angles are two angles that add up to 90. If one is the complement of angle 2, and they tell you that angle 2 is 40, then what would angle 1 have to be? Well, they add up to 90, so wouldn't it have to be 50, right? Does that make sense? Okay, if one's 60, the other one's 30. The complement of that 60-degree one is the 30-degree one, right? Okay, next one, supplementary angles. They're two angles that add up to 180. Okay, these two, 120 and 60, if you add those up, that's 180, right? Okay, these two, angle car plus angle rag, car and rag equal to 180, right? Because they're both on a straight line. A straight line is 180 degrees, which is half a circle, which is 360, right? So that's 180 to here. So these two angles right here add up to 180. So they're supplementary as well, even though they're connected, right? These aren't connected, but both of them are supplementary angle pairs. Okay, so if that one was 130, then this one you would subtract from 180, and its supplement would be, you could plug it into the formula actually if you wanted to. You could say 130 here and x here and subtract 130 from both sides, and that's 50. But 180 minus 130, that gives you 50 degrees, right? Okay, supplementary angles, like I said, two angles that add up to 180, and they're supplements of each other. If one is the supplement of 2, and 2 is 60, then the other has to, help add up to 180, so that's got to be 120. If it was 110, then it would be 70 for the other one, the supplement, okay? All right, let's move on. Adjacent angles. Adjacent angles are connected angles. They're connected by two things. They're connected by the vertex. In other words, HAG, this angle right here, HAG, and I don't know if I use MAG or GAM. Hang on, let me check. Okay, HAG and MAG. Okay, so HAG and MAG are adjacent angles because they share a common side. That's this AG side. They share that side. These two angles share the side, and it has a common vertex. Okay, both angles share this vertex, so they're connected, right? All right. So what about rig? That's this angle over here, RIG, and fit. Are they adjacent angles? Well, they share a vertex, which is correct, but do they share a common side? No, they don't. Okay, so they're not adjacent angles. Here's some non-adjacent angles. Okay, they're separated, right? They don't share a side or a vertex. These are all non-adjacent angles, right? All of these are non-adjacent angles. Okay. Next, let's talk about linear pairs. Okay, a linear pair is a line pair. Okay, it's a line pair. There's two angles on a straight line. In other words, they're supplementary, obviously, because there's two angles on a line, and they're adjacent because they share a vertex and a side. So a linear pair has these two qualities always about it. Adjacent angles, and they have to be supplementary. Okay? So are these two right here adjacent, or a linear pair? I'm sorry. Are they a linear pair? Okay. No, they're not. Why? Okay, they're supplementary. That's part of the definition, but they are not adjacent, are they? They're not connected, okay, by vertex and by side. Next, are all linear pairs supplementary? Are all linear pairs supplementary? Well, of course. Linear pairs, supplementary is part of the definition, okay? Are all supplementary angles linear pairs? No. Okay? The counterexample would be this picture, right? Okay? And a counterexample is something you're going to be using throughout geometry where you disprove something by showing something false. Like, say your girlfriend said, hey, I was at the mall, the other day. I didn't go to play putt-putt golf, whatever, I don't know. I didn't go there. And then somebody tells you, look at this picture. I got a picture of you at putt-putt. You lied to me. You lied to me. Anyway, so you proved it. You proved her wrong, right? So basically supplementary angles are linear pairs. It's false because here's the counterexample. I just showed you a set of supplementary angles that were not linear pairs, okay? So that one's false. Okay, vertical angles. When you have intersecting lines, vertical angles are the opposite angles, okay? Those are the opposite angles, okay? So 1 and 2 are vertical angles. Also, 3 and 4 are vertical angles. They're opposite as well. And the nice thing about vertical angles is that they're always the same size. They're congruent. If I'll show you in class, probably before you see this, but these whenever you move the intersecting lines, these angles the opposite angles stay the same size. So vertical angles are always congruent. Okay. All right, linear pairs. Look at this. Are these two angles congruent or are they supplementary? Because it makes a difference as to how you set up the equation, right? Remember we talked about addition versus congruent? Okay? Are these the kind that you're going to add together and set it equal to something, or are you going to set them equal to each other? Okay? These are supplementary. Okay? So this is angle addition, right? So 4x plus 5x equals 180. You combine and then divide by 9, right? And x is 20, right? So you plug in the 20 into here, and that's 80. And then you plug in the 20 into x here, and that's 100, okay? So if they're supplementary like this, then you add them together and set them equal to 180, okay? Here's another one. Is this one the congruent kind or supplementary? Well, of course, it's the linear pair kind, so it's angle addition, okay? So you say 3x plus 6x equals what? Yeah, 180 because it's on a line. Okay, so 3x plus 6x equals 180. You solve it for x and you get 20. You plug them in, 20 into here. 3 times 20 is 60, and then 6 times 20 is 120, right? Okay, now from the vertical angle perspective, would these two be something where you say this one plus this one equals something, or would you say that they're congruent? Okay, are they congruent or supplementary? They're congruent, aren't they? Okay, anything that's congruent you can set equal to each other, right? And then solve. So since vertical angles are always congruent, you set them equal to each other, and then you solve. If you have x on both sides, you get rid of the smallest x first, right? That's gone. And then you just keep solving. You add 8 to both sides, and then 4x, you've got to get rid of the 4, so you divide by 4, and x is 7. Okay, so you just plug into the x, and basically 3 times 7 is 21, plus 20 will be 41. Okay, and then same thing over here. It should be the same, right? If you plug 7 times 7, it's 49 minus 8 is 41 as well. So yes, it worked. Okay, here's another one. Are these vertical angles where you set them equal to each other, or are they linear pairs where you say first one plus second one equals 180? Nah, they're congruent. They're vertical angles, right? So you set them equal to each other. We just did something just like this a second ago. So we're going to subtract 2x from both sides. We got to get rid of that 40. So now we have x is 30. And then you plug 30 into both of these guys, right? And you'll get 130 for this one and 130 for that one. Okay? All right, in summary, congruent angles. These are congruent angles. So what do you do with them to set up an equation? You set them equal to each other, right? And then solve. Plug back in. Okay, congruent angles, you always set them equal to each other. Just like we did last time, if this is an angle bisector, right? Just bringing this back. If this is an angle bisector, are these congruent angles? Aren't they the same size? Because it chopped it in half into two baby angles that are the same size, right? So you set those equal to each other as well. Okay? So there's several types of angle addition, right? The first kind that we talked about last time was that these two angles add up to the big angle, right? And I didn't write a big angle, so I'm just going to say equals to whatever it is. Like this one looks like it's about 75 or so, maybe 80, probably 75. Anyway, so you put 75 here. That's angle addition. Okay, here's another type of angle addition that has to do with complementary angles. Remember, complementary angles are two angles that add up to 90. I'm sorry, complementary is 90. And so 6x and 3x, you add those together and set it equal to 90. Why? Because there's a box there. Okay, they're complementary angles. They add up to 90. And then you've got this linear pair here, right? Linear pair, two angles on a straight line, right? Linear pairs are supplementary. They're adjacent. Okay, so whenever you do this, it's another type of angle addition. So 6x plus 3x equals what? Equals to 180, right? You get it? Okay. So all complementary angles are adjacent angles. Is that true? If it's not, you need to show me a counterexample. If it's false, then we need to show a counterexample. Okay? Oh, there's one. These are complementary angles, and they're not adjacent. Okay? So that proved that this statement is not always correct. Okay? Next, all supplementary angles are linear pairs. Well, we could disprove that one too, because it's false. These two are supplementary, but they're not linear pairs. So I just disproved this statement. I proved it false. It was a counterexample. Okay, now all linear pairs are supplementary angles. That's true. Why? It's part of the definition. If it's a linear pair, they add up to 180, right? Okay, all linear pairs are adjacent angles. That's part of the definition as well. So that's true. Okay? For it to be a linear pair, it has to be supplementary and it has to be adjacent. That's the definition of linear pairs. So linear pairs are going to have all the time, every single time, going to have adjacent angles. Okay? Very good. We are done. Let me turn it off now. Bye. Stop.